So this is whose structure, children? This is of a 5 carbon hydrocarbon. That is what? Pentane. What is this? Pentane, isn't it? And what is the formula? C5H12. Okay. So now this is when it is existing in a straight chain. Okay. So now when it exists in a straight chain, the formula goes as what could be the condensed formula? CH3, CH2, 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 and 1, 2, 3, 4, 5. Yes, CH3. So this is the straight chain formula of water pentane. But I wanted to construct a closed pentane. So what will I do? I will make the two ends of the carbon to meet each other. So I will remove it from here and I am going to link it to this carbon. Okay, so thereby what will happen? A closed pentane structure will be formed, which is called as water cyclopentane. Now observe this, children. So when the two ends of the carbons are linked, the structure of the pentane becomes somewhat like this, which is termed as what? It is going to be termed as cyclopentane. What is this going to be termed as? Cyclopentane. Now observe, will the formula remain the same? Okay, let us see. Now if you observe in the straight chain, the two terminal carbons had how many carbons? How many hydrogens? Three hydrogen atoms. The terminal carbons were linked with three hydrogen atoms. But observe here all the carbon atoms are sharing their electrons with only two hydrogens. Then where are the remaining two electrons are shared with? With the two carbons. If I observe here, okay, if I observe, let me take from this one. So this is sharing with this one electron with this carbon and another electron with this carbon. Similarly, this carbon is sharing with this electron as well, one electron with this carbon and this. Similarly, this one. Okay, so you see now each carbon will share two electrons each with carbon and similarly two electrons each with hydrogen. Then let us now check the formula, whether the formula is similar to this of normal pentane or not. So normal actual formula of pentane is what? C5H12. Now let us see what would be the formula of cyclopentane. Count the number of carbons. 5. So there is no difference in the number of carbons. So C5. Let us see the hydrogens. 2. Okay, I'm starting from here. 2, 4, 6, 8 and 10. So the formula of cyclopentane becomes what? C5H10. So are they similar, children? No. Now can you recall this formula resembles whom? Yes, it resembles that of normal pentane. Whose formula? It resembles the pentane. So you see now that the cyclopentane will have a formula similar to that of a pentene. So can I say these are isomers? Yes, these are. That is what the fourth category which we were talking about, ring chain isomers. Okay. So here the formula of a cyclic saturated hydrocarbon. Okay, now because all there are single bonds, we call this as what? A cyclic saturated hydrocarbon, and that formula will resemble to that of what? Of an unsaturated normal hydrocarbon. Okay, children. So this is, so what is happening when the carbons are going to close themselves? The two hydrogen, each hydrogen from the carbon is removed and they form a bond with the carbon itself. Okay. Similarly, you observe this is what? If I just take this is a chain of 6 carbon hydrocarbon. That is 1, 2, 3, 4, 5, 6. What is that called as? Hexane. Now this hexane is an open structure. Okay, that is a chain. Now when I close it, I will see that the hydrogens are removed and they are now directly bonded to carbon. So now what will happen to the one of the hydrogen? It is going to be from each carbon hydrogen is going to be removed. Thereby now it forms a closed structure. So now observe, each carbon is associated with only two hydrogens. Let us represent these as what? Hydrogen. So 2. here as well 2, then here as well 2, and here as well 2, and here. So all the carbon atoms now in a cyclic hydrocarbon will be now bonded to 2 hydrogen atom each, in which kind of hydrocarbon? Saturated hydrocarbon. Now what is this 6 carbon hydrocarbon? It's a hexane. And which kind of hexane? Cyclohexane. Now if I cyclohexane, if I write, if I draw the structure, it would be somewhat like this. Okay. So now let us see the arrangement of hydrogens. Each will be now bonded to how many hydrogens? 2 hydrogens. So now what could be the formula of this compound now? As I told, it will be similar to that of alkene. So C6H12, cyclohexane. Okay. Similarly, now tell me, from which atom, from which carbon we can, hydrocarbon, we can construct hydrocarbons. We can have it from where? From propane. Okay. So let me show. If suppose propanes are 2. So 1, 2, 3. So this is a closed chain. Similarly, we can even have for butane. Okay. So closed chain. It may not be exactly cyclic, but they are the closed chain structures. Okay. Let me show you another example. Okay. This is of what? Pentane. This is what? Pentane. 1, 2, 3, 4, 5. What we have discussed earlier. This is hexane. Similarly, this is which one? This is butane. Okay. And the other one of propane. Okay. Let us see propane. Propane, little, since it is and this is of propane. So like this, the cyclic hydrocarbons are formed by closing the 2 end carbons to each other, and when they get closed, they are going to be bonded by removing 1 hydrogen atom from each. So that's why 2 hydrogens will be less in a cyclic saturated hydrocarbon. Okay, children. Now, what about the cyclic unsaturated hydrocarbon? Now, about that, we are not discussing much in detail here in this class. You will be learning about them in your higher classes. Right now, just I will take one example of an unsaturated cyclic hydrocarbon, that of a compound called as benzene. Okay. What is this called as? Benzene. Okay. Now this benzene is a hexane compound. It is a hex compound. That means it has how many carbons? Yeah, 6 carbons. Okay. So let me put them. 1, 2, 3, 4, 5 and 6. Now, this benzene is a special kind of aromatic hydrocarbon, about which you will be learning more in detail in the higher classes. But remember, aromatic means which will give beautiful fragrances. Okay, not beautiful, which will emit some smell. Okay, so aroma. Now, let us see, in this case, there would be a double bond existing at each alternate carbon-carbon link. Okay, let us assume, if I give a numbering 2, 3, 4, 5, 6. So now this is the double bond is existing between the first and the sixth carbon. Similarly, between second and third carbon, between fourth and fifth carbon. Now then, let me just guess, children, what could be the formula? Okay, now since there is a double bond existing, how many hydrogens would be there? Okay, now count. So already this carbon is joined with 1, 2, 3. So only one more hydrogen it can bond with. Come to the second carbon. 1, 2, 3. So one more hydrogen. Then similarly this one, 1, 2, 3. So this is 4. Similarly this one, if you can count now, 1, 2, 3, and this is 4. Then come to this fifth carbon, 1, 2, 3, and this one is 4. Similarly, sixth carbon, 1, 2, 3, and the fourth is hydrogen. Okay. So, therefore, 3 electrons are shared between the carbons, and the one each left electron left with the carbon will be shared with hydrogen. Now what would be the formula? C6. And how many hydrogens? H6. So the formula of benzene is what? C6H6. But there is an interesting thing about benzene, children. Now, as I told you, the double bonds are alternating with each other, isn't it? But these are not stable. That means they can be constantly shifted. Okay. So if once it is between first and sixth carbon, it can be sometimes between first and second carbon. Similarly between third and fourth. Similarly between fifth and sixth. So they keep on rotating. Okay, so that's why the carbon double bond may not be necessarily between first and sixth, but it can be between first and second as well. But only thing you need to remember is they are at alternate positions. Okay, and this is called as benzene. Okay, and what kind of cyclic hydrocarbon is a benzene? It's a cyclic unsaturated hydrocarbon. Okay, children. So this we learnt about what, children? About the isomers and the cyclic hydrocarbons. Now one more point, children. When we are representing symbolically in the with lines also, we can represent the hydrocarbon compound. So it all depends upon, like suppose I am representing like this. So what is this? Now each of these points are nothing but the carbons. Now how many carbons? There are 3 carbons. So that's why it's a prop. Similarly, if suppose I draw it like this, so what could it mean? It means it's a propene. Okay, this is a propane and this is a propene. Suppose if I draw it like this, yeah, this is a propine. Fine. So they also can be, hydrocarbons can also be represented like this. Okay, suppose I write like this. So how many carbons now? 1, 2, 3, 4, 5. So this is pentane. Okay. Now if I put a double bond, it becomes 1, 2, 3, 4, 5. So pent. But what kind of this one? E. And where is the double bond located? On the second carbon. So 2 pentane. So, and if suppose I draw it like this, okay, so what is this? This is a branched one. So 1, 2, 3, 4. That is but. And where is the branched, where is a methyl group being attached? To the second carbon. So 2-methyl butane. So hydrocarbons can also be represented in the symbolic pattern. Fine, children. So I hope you are clear with this part. So further we'll continue in the next session. Thank you. Have a good day.